Come and make jelly with me whilst I talk about some of the ways that gelatinous zooplankton's common features allow them to thrive in such a diverse range of communities. Gelatinous zooplankton's translucent tissues allow them some camouflage as they're harder for predators to spot in the water column. This helps them avoid being eaten in epipelagic and mesopelagic waters where predators are more likely to rely on sight to find prey. Some gelatinous zooplankton have cilia that they can beat in order to move around, or other forms of weak propulsion that help them to collect food particles, which is especially useful as many gelatinous zooplankton filter feed, collecting marine debris in the water column using a range of different techniques that will be explored later on in this sway. You may have noticed this is red jelly, and this is because many gelatinous zooplankton found in the deep ocean have red pigments. In fact, when this is turned out, it will hopefully resemble a deep-sea crown jellyfish like the one in the photo for this slide. This red pigment makes them invisible to predators, because red is the first colour to be lost during the attenuation of light with depth. Alternatively, other deep-sea organisms may use bioluminescence to communicate, attract mates, or intimidate predators. The lack of complicated structures in many gelatinous zooplankton, such as jellyfish and comb jellies, also means they're easily able to survive at the high pressures and low temperatures that come with increased depth. Colonial organisms, such as siphonophores or Portuguese men-of-war, are able to share resources and have specialized zooids that perform functions for the organism, such as reproduction or defense. Colonial organisms are usually found in low-energy surface waters, as they're easily broken up. This is due to high water content of their tissues, making them particularly fragile. However, this high water content also means they have a low density, and as such can achieve neutral buoyancy to float in the water and be carried by the current whilst expending little to no energy. The low nutritious value of gelatinous zooplankton's tissues allow them rapid growth, so they can reach a larger size than other zooplankton. This makes it physically more difficult for some predators to eat them and also makes the balance of energy gained versus energy expended in consuming them less worthwhile. This is especially helpful in shallower waters where predators are more abundant. Gelatinous zooplankton thrive in oligotrophic and oxygen-depleted regions, so they're able to thrive where other species may not be able to survive in waters globally and vertically in low nutrient bands in the water column. These are some of the reasons why gelatinous zooplankton are one of the most abundant and widely distributed classes of zooplankton.